Okay, this is section 2.2, and we're going to talk about linear relations and functions. We should already know what a relation is from section 2.1, and we should be able to tell what a function is from section 2.1. So now we're going to talk about linear relations. A linear relation is a relation that has a straight line graph. That's why it's called linear. It forms a line. And relations that are not linear are called nonlinear relations. So an equation like x plus y equals 5 is called a linear equation. If we graphed this, it would form a straight line. Okay, so these three things right here are going to tell you how to determine whether something is linear or not without having to graph it. First of all, a linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. And I'll show you what that looks like. Okay, the variables may not be multiplied together, or there cannot be a variable in the denominator. And then a linear equation does not contain variables with exponents other than 1. So it can't have like an x squared or something like that. All right, so what we're going to do is we're going to just follow those little guidelines to figure out if the equation they give us is a linear equation. Now, we're going to start seeing something like this now. Instead of seeing y equals something, now we're going to use this notation, f of x, and that just stands for the function. It basically just replaces your y. You're not going to do anything with it. Instead of saying y equals something, f of x equals something. So we're looking at this part of the equation, 8 minus 3/4 x. So if it's kind of hard for you to tell what that would look like, that's what it looks like. So we have to figure out, does it apply, do all these rules apply? Because we have to say yes or no, is it linear? Well, let's see. I have to have all operations, addition, subtraction, multiplication, which I do. The variables may not be multiplied together, so I only have one variable, so I don't have to worry about that. The variable cannot be in the denominator. I don't have to worry about that. And I can't have anything other than an exponent other than 1. So this is x to the first. So I would say yes. Okay, and we're just going to explain the no ones. Okay, so this one, part B, is f of x equals 2 over x. Well, we should automatically recognize that I have a variable that appears in the denominator, and that can't happen. When I graph this, it is not going to form a straight line. So I'm going to put no, and then I'll put because variable in the denominator. Okay, so far pretty easy. I think we have two more. So 3xy minus 4. So look back at our rules. Okay, and if you'll notice, I have two variables here, an x and a y, and they're being multiplied together. I can only have one variable in my problem. Okay, and again, they use g of x this time instead of f of x. Same thing, this is just basically replacing our y. So this would be no, it's not linear, because I'm just going to say two variables are being used. Okay, so let's look at D. F of x equals 5 over x plus 6. So yes or no, is this a linear relation or a linear function? And we're going to say no, because I have a variable in the denominator. Variable in denominator. Okay, so that's pretty easy. We like those. Okay, so now let's look at a word problem. It says the growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches x days after initial measurement. How tall is the sample after 3 days? Well, it says x stands for days, and we know we have 3 days. So here's how we write that. If we're supposed to substitute 3 in, I'm going to say f of 3, and that just means instead of x, I'm plugging 3 in for my x. 5.9 times x plus 3.25. And now I'm just going to work, I didn't put my 3 in there. So instead of that x, that needs to be a 3. 5.9 times 3 plus 3.25. So when we put that in our calculator, 5.9 times 3 plus 3.25, 20.95. So it says how tall is the sample? It's 20.95 inches. Okay. So now it says the term 3.25 in the function represents the height of the grass when it was initially measured. So the very first day it was 3.25 inches. The sample is how many times as tall after 3 days. Well, we're going to take our answer. So after 3 days, it was 20.95 inches. So this grows really fast. And if we want to know how many times as tall is it? Well, let's divide it by the initial measurement. So 20.95 divided by 3.25, 6.4. We'll go 6.4. So it's 6.4 times as tall as it was that first day. So we took our initial, or how tall it was that third day, and divided it by our initial height. Okay? Then they're going to have us, or they're going to show us what the standard form of an equation looks like. We have lots of different forms, and you probably remember some from Algebra 1. Slope-intercept form, point-slope form, and then we have standard form. Standard form of a linear equation always has your x's and y's on the left side and a number without your x or y on the other side. A, B, and C, those just stand for integers or numbers with the greatest common factor of 1. I'll show you what that means. And A and B are not both 0. So here's an example. This is an example of a line written in standard form. If I told you to identify A, B, and C, A in this problem, A will always be the problem next to your x, but you have to make sure your x and y are on the left and the other numbers on the right. My B in this problem is 5, and my C in this problem is 12. Okay, so let's do example 3. We want to write this in standard form. So first of all, standard form, we're not going to leave any fractions in our answer. So if I have negative 3/10 x equals, I have 2 equal signs in that one. I don't know why. Let's change this to a plus. I don't know what it's supposed to be, but we'll say it's going to be a plus. So negative 3/10 x equals 8y plus 15. We can't have fractions in our answer, so we need to get rid of that 10. And the way we're going to get rid of that 10 is we're going to multiply every single thing by 10. So this one, do you see my 10s will cancel? And I have negative 3x. If I multiply this side by 10, I get 80y plus 150. Okay, so now we want our x's and y's on the same side, so I need to bring this 80y over. So I'm going to subtract 80y. I'm going to put my answer right up here. Now, these are not like terms, so I can't add them together. I'm just going to write them down. Negative 3x minus 80y equals 150. Okay, so we're almost done. Okay, the other thing that they tell us is A and B have to be greater than 0. Or I'm sorry, A has to be greater than or equal to 0. So they don't want this A to be a negative number. So I can fix that by multiplying everything by a negative 1. So when I do that, it changes the signs on every single number. So this is the linear equation written in standard form. They also want us to identify what A, B, and C are. So A is 3, B is 80, C is negative 50. Okay, so let's do example 4. I have 2y equals 4x plus 5. We know that we need our x's and y's on the same side, so I'm going to subtract 4x. And now I have negative 4x plus 2y equals 5. The rule is my first number with my x cannot be negative, so I'm going to change the signs on all of them. So it's going to be 4x minus 2y equals negative 5. And now I'm going to identify my a, b, and c. A is 4, b is negative 2, you have to put that sign with it, c is negative 5. Okay, so that's how we write something in standard form. All my x's and y's have to be on one side, the number without something on the other side, and then identify your a, b, and c. The last type of problem you're going to have is we're going to start graphing some things. And we're going to graph these by finding our x and y intercepts first. So I gave you some notes up here how to find the x-intercepts. To find the x-intercept, we're going to plug 0 in for y and solve. And to find the y-intercept, plug 0 in for x and solve. So I'm going to take, let's do our x-intercept first. Okay, so I'm using this equation. And it says to find the x-intercept, plug 0 in for y. So this y right here, I'm going to put 0. So I have 2x minus 3 times 0 plus 8 equals 0. 2x, this is just 0 now, plus 8 equals 0. Subtract 8. 2x equals negative 8. So when I divide by 2, x is negative 4. So when I say x-intercept, that's where it's going to cross my x-axis. So I know it's crossing my x-axis at negative 4. So now let's do our y-intercept. So to find the y-intercept, plug 0 in for your x. So 2 times 0 minus 3y plus 8 equals 0. This is just 0 now. Negative 3y plus 8 equals 0. Subtract 8. Negative 3y equals negative 8. Divide by negative 3. So I get y equals a positive 8/3. Or that's what? 2 2/3. So pretty close to 3. So my y-intercept, that means it crosses my y-axis at 2 2/3. So not quite to 3. And then to draw a line, we only need 2 points. So now I can draw that line in. Mine's going to be really, because I have to just kind of guess how I'm going to draw that on there. And I'll give you rulers to do that. All right, let's do one more. Find the x and y intercepts. So let's find our x-intercept first. To find the x-intercept, we're putting 0 in for y. So I have 2x plus 5 times 0 minus 10 equals 0. 2x, this goes away, minus 10 equals 0. Add 10, 2x equals 10. So then when I divide by 2, I get x equals 5. So I know that my x-intercept is 5. And remember, this is your x-axis, here's your y-axis. So now we're going to do our y-intercept. To find your y-intercept, plug 0 in for x. So I have 2 times 0 plus 5y minus 10 equals 0. 5y minus 10 equals 0 because this is 0. Add 10. 5y equals 10. Divide by 5. So y is 2. So my y-intercept crosses the y-axis at 2. And then we can draw our line in to graph it. Okay? So I will give your assignment in class, and I will talk to you later.